far we talked about measures of center, which is how to find the center of a set of data. There are three options for measures of center. What were those three? Mean, mode, and median. And then the second thing was measures of dispersion, which is how spread out the data was. What are the options for measures of dispersion? Range, standard deviation, and the last one? Variance. Yeah. So you can do standard deviation for a population or a sample. And then variance was the last option there. So the next piece, we have a couple rules. The empirical rule does not apply to every set of data. It only works if you have bell-shaped data. Okay, so we know that means nice, symmetric data. Then we could apply the empirical rule. And so it tells us that approximately 68% of the data will lie within one standard deviation of the mean. 95% will lie within two standard deviations. And 99.7% will be within three standard deviations. I think on the formula sheet that I've given, it has the empirical rule and it has those three bullet points there. So what that means is if I have a set of data, okay, and let's say the mean is 50 and the standard deviation is 5. So here's my mean, the center. So we know in bell-shaped data, the center is the mean. Okay, that one standard deviation would be from here to here. So my standard deviation is 5, so that's 5 below and 5 above. So 45 to 55 would be one standard deviation. So if I'm looking at the actual data, if I looked at the list of actual values, 68% of them should be somewhere between 45 and 55. Does that make sense? So two standard deviations. So two standard deviations below, if you subtract another 5, that would be a 40, and this would be a 60. So two standard deviations is everything from 40 to 60. And the empirical rule says how much of our data should fall there? %. So if I had 100 values, I would expect 95 of them to be some number between 40 and 60. And then 3 standard deviations. So if you subtract, again, 99.7% of the data should be a value between 35 and 65. That's what the empirical rule says. It only applies to bell-shaped data. So if it's skewed, it will not work. Does that kind of make sense? The picture on this previous slide, I kind of gave you a breakdown a little bit too. I have all these percentages. So if you think about, I told you 68% within one standard deviation, so you would expect half of it above and half below. So 68 divided by 2 is 34, so 34 and 34. 95% in 2 standard deviations. So 95 divided by 2. 47.5. So 47.5% should be in this window. Okay, so if this was 34, that means this next section is 13.5%. And then you get the tails there. So does that kind of make sense how I got those percentages? That's not something that you necessarily have to memorize, but you might be asked a question on homework like, what % of the data would fall 2 standard deviations above the mean. And so you might have to kind of think about that a little bit. All right, let's look at an example with this. So the following data represents cholesterol for 54 patients. All right, I already gave you a graph. Is this a perfect bell shape? No. Is it reasonably close? Yes. So because it's somewhat bell shaped, we can use the empirical rule here. So the question, determine the percentage of patients that would have a cholesterol within 3 standard deviations of the mean according to the empirical rule. So empirical rule says how much should be within 3 standard deviations of the mean? 99.7. I didn't ask you from the actual data, I just said based on the empirical rule, what should it be? So it should be 99.7. B. Determine the percentage of all patients that have HDL between 34 and 69.1 according to the empirical rule. If I'm going to do that, I kind of need to know my mean and standard deviation, don't I? What's the fastest way to get that? Calculator. All right. It says of the 54 female patients. So do we think that's all of his female patients? Kind of the way it's stated, of the 54, kind of makes it sound like those are the only 54. So if we did that, our population standard deviation would be 11.696, so 11.7. You might have mistyped one value to change everything.
Well, I typed too many.
You typed too many? That might have something to do with it. Okay. So let's figure this out. I'm going to use, where did I have the graph? I'm going to use this to kind of help us reason. So in this scenario, we said the mean was 57.4. So that's the middle. Standard deviation is 11.7. So to get one standard deviation above, you do 57.4 plus 11.7. Okay, if you want the others, you just keep adding 11.7. And to get the ones below, we're subtracting the 11.7. Now this picture isn't required, but I'm just putting it on here to really illustrate what I'm talking about. You guys all see where I got those numbers. I had my mean, and I just added my standard deviation for the above and subtracted it for below. So my question is, I want to know what percentage would be between 34 and 69.1. So here's 34, 69.1. So I need to know how many are going to fall in this window. Now from here to here, this was one standard deviation. We know how much is that?
68%.
That's 68%. How do I find this little chunk? So we have to think the 95% divided by 2 to get above and below. And if we wanted to subtract off the 34% that was already here, that's 13.5. Isn't that what we had on the original empirical rule picture? So, if we add all those together, we get 81.5. So 81.5 should be somewhere between 34 and 69.1. All right, let's see how close the real data was. I want to know the actual percentage. So we know there were 54. Let's count. How many of these original numbers were somewhere between 34 and 69.1? Of them. Double checking. So that as a percentage is 83.3%. Was it an exact match? No. Was the empirical rule a pretty good estimate? Yeah, not too bad.
Okay, so on the, how do we get 81.5?
Okay. So think about this picture for a minute. So if we think about the rules, first standard deviation we know is 68%. So if you divide that by 2, that means you have 34 in each of those chunks. Next section is 95. So if you divide that by 2, you get 47.5. So that's this piece. If you subtract off the 34 we've already used, that leaves you 13.5. Okay. So, and if you needed the last one, you would do the same thing. 99.7 divided by 2 and subtract off the ones we already know. So we wanted between 34 and 69.1. So basically we had to add these 3 percentages together. Other questions? If we don't have bell-shaped data, the best we can do is Chebyshev's theorem. So this is Chebyshev's, yes. Under the empirical rule, so it's 1 minus 1 over k squared %. So for instance, if I said how much would be within 1 standard deviation, okay, your k is the number of standard deviations. So if I look at this, if I wanted to determine the percentage of patients that have cholesterol within 3 standard deviations using Chebyshev's. So my k here would be 3. So we do 1 minus 1 over k squared. So it gives us 88.89%. Okay, so empirical rule is for bell-shaped. Chebyshev's is for any set. That would be our best guess. Notice it's a lot lower, isn't it? Chebyshev's is giving us almost 89%. Empirical rule said 99.7 because when your data isn't bell-shaped, you're allowing for more to be on the ends. So less of it is going to be in the middle. So I'm going to skip this one. Let's just skip that. All right, last thing that we're going to talk about a weighted mean. So you think of that happens like with your GPAs. A's are worth 4 points, B's are worth 3 points, C's are worth 2 points. So it's when you have an average, but different values have different weights. So basically what you have to do is take your value times its weight. We add those together and divide by all the weights. So if I'm looking at your grades and you had 3 A's, 2 B's, and 1 C, and you wanted to know your GPA. How much is an A worth? How much is a B worth? A C is worth. Okay. And then if I think about this, I'm essentially dividing by the number of classes.
6.
So we divide by 6. So if I tally that up, your GPA is 3.33. So let's do a weighted mean average. So Bob goes to a by-the-weight nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate-covered peanuts, and 1.5 pounds of cashews. Raisins are $1.25 per pound. Chocolate-covered peanuts are $3.25 per pound. Cashews are $5.40 per pound. What is the cost per pound of this mix? Okay, so we have to add up the number of pounds, but we have to take it times the cost is like its weight. So he had 1 pound of raisins, and those cost $1.25. So 1 times the 1.25. All right, we have 2 pounds of chocolate-covered peanuts, and those are $3.25. We have 1.5 pounds of cashews, and those are $5.40. Sometimes the hardest part for people is figuring out what to divide by, so here's a little trick. We're finding the cost per pound. That means the top of this fraction should be the cost, the bottom should be the pounds. So my bottom is the total number of pounds that we purchased. So we had 1 of raisins, 2 of chocolate, and 1.5 of cashews. Does that make sense to me? Okay. So then we his total cost was $3.52 per pound.
Oh my goodness.
That's really the end, but I did put one more empirical rule example on here because sometimes people struggle with that one a little bit. So I was going to maybe give you guys a couple minutes to read that question, and I put a blank bell curve there if you need to write some numbers in that. See if you can figure it out on your own before we talk about it together. Did you guys fill in the numbers on this to help you? So the mean's 84, so to get your standard deviation above, you add the 5. And below you would subtract it. So if I want between 74 and 94, and I'm looking here, how many standard deviations is that? 2 standard deviations, so we know empirical rule, 2 standard deviations is 95%. All right. lower than 79, so we kind of have to do a little math here and figure this out a bit. We've talked about some of these percentages already. We know first standard deviation is 68, so that's 34% in each. 95, which gave us how much in this little window? Okay, 3 standard deviations is supposed to be 99.7. So if you want to start figuring out those percentages, you have to do 99.7 divided by 2, because we have half above and half below, and subtract off the 2 we filled in. So subtract off the 34 and the 13.5. So this will be 2.35. You guys understand where I got that number? How would I get this last part here if I wanted it? Yeah. Finish off. We know it should be 50% on each side, right? So we could do 50 minus 34 minus 13.5 minus 2.35. All right, so we have all of these percentages filled in. So then I wanted to know lower than 79. So you're going to add 0.15 plus 2.35 plus 13.5. You guys understand that?
How do we find 0.15?
So a couple ways you could do it. What I did is 99.7, divided that in half, and then subtract off
All of those.
yeah.
Just those two.
Yes, because we were finding this 2. You were asking how we found the 2.35?
0.15.
Oh, okay, sorry. What I did was just the 50% is below, so I did 50 and subtracted off those 3. All right, final question. We had to find what percent were between 69 and 94.
There's another question after.
So 69 to 94. So basically you add all those, and what do you get? 97.35? Keep forgetting to change my highlighter. Alright, final one. What percent were above 99? So here's 99, so above that would be 0.15%. Alright, so you have the rest of the hour to work on that assignment from yesterday. Ask me questions if you need